ball from a point A with initial velocity of 35 meters a second at an angle of alpha above the horizontal, where sine alpha equals 0.8. The ball passes over a tree which is growing in front of the lake. The lake is 100 meters wide as shown in the diagram. The tree is at a horizontal distance of 17.5 meters from A. So first thing we want to do is determine whether or not the golf ball will fall into the lake. So in order to do this, I want to organise a couple of bits of information. First bit of information is just to actually look at the horizontal and vertical components of our velocity. We're told that it starts off 35 meters a second at an angle of alpha. Now, what I know is sine alpha equals 0.8, so that's the same as writing it as sine alpha equals 4/5. So I can use the following triangle, because alpha, and so sine alpha opposite over adjacent gives me 4 and 5, and you're going to recognise this as the 3, 4, 5 triangle, and that can help us with this question and make the question a little bit easier. So working vertically, uy equals 35 sine alpha, so 35 times 4/5 is 28 meters a second. Working vertically, so ux is going to be 35 cos alpha. 35 times 3/5, so 3/5 gives me 21 meters a second. Okay, now I want to find whether this ball is going to fall into the lake, so I need to check what the range of the ball is, and so we're talking about horizontal displacement. The horizontal displacement is just going to be 21t, so sx horizontally, sx will just be 21t, since there is no acceleration horizontally, and so it's just going to be a case of speed times time. Distance equals speed times time. So now I've got to work vertically, because what I need to do is I need to find when the displacement of the vertical displacement of the ball has returned to 0, because we're talking about path up and over. So we want to know when is s 0 vertically, knowing that u is 28 and that the acceleration because of gravity is minus 9.8, and we're trying to find what t is equal to. Equation that links all of the 4 variables is s equals ut plus a half at squared. So substituting our values in, we get 0 is equal to 28t minus 4 half of 9.8 is 4.9 t squared. So factorising this, I can take out a factor of 0.7, so I get 0 equals 0.7 t, so I can take the t outside, and so I get 40 minus 7 t inside the bracket. So this obviously then gives me t equals 0, which is the start point, but then t equals 40 over 7. And I'd leave that as an exact answer. So now the distance travelled, let's say, go back to horizontally, so that we can identify that. S equals 21t and t equals 40 over 7. So S will be 21 times 40 over 7, which gives us 120 meters. Now looking back at our diagram, the range is 121 meters and this length is 117. Therefore, the ball will not land in a lake, or the ball will clear the lake. Okay, so let's have a look, see how marks are awarded in this question. First of all, there's a standalone mark if you calculated that the vertical component of the velocity is 28, and there's a standalone B1 mark if you calculated the horizontal velocity is 21. Next, if you've identified the correct variables and formula, then you get a method mark, and you then get an accuracy mark if you've substituted it into the formula correctly. Finally, you're going to get an accuracy mark if you've got the correct times. The last mark is then given if you found the 120 meters and stated that it will clear the lake. Okay then, now let's have a look at part B. Part B says find the magnitude and direction of the velocity of the ball as it passes over the tree. Now, horizontally, if we think about this, the velocity equals 21 at all times. But what I want to know is what is the vertical velocity. And in order to calculate that, I need to know the time when the golf ball has been displaced horizontally by 17.5 meters. So what I'm looking at here is S equals 17.5, and I want to know what the T equals, and I can still use that equation that we had earlier, S equals VT, 21T. So what I get is 17.5 is equal to 21T, and if I divide by 21, we get that the time equals 5/6 of a second. Now, vertically, we now know that T equals 5/6. We still know that U equals 28. I know that A equals minus 9.8, and I'm looking to find V. So the equation I need to use here is V equals U plus AT. Substituting our values in, I get V equals 28 minus 9.8 lots of 5/6. And when we work through this, I get an answer, and I can give an exact answer here of 119/6 meters a second. Now what this tells me is that at the instant it passes over the ball, passes over the tree, has a horizontal component of 21 meters a second. It has a vertical component of 119/6 meters a second. I'm looking to find the magnitude. So what I want to know is this resultant size of our components, and I want to know this direction, so this angle here. So R is given as the square root of 21 squared plus 119/6 squared. If we put this into our calculator and work through this, you get an answer of 28.89 meters a second to 2 decimal places. Finally, I want to know what the angle, what the direction of this is. So what I know is tan alpha will be opposite, which is 119/6, divide by 21. So taking tan to the minus 1, the inverse function of tan of both sides, I get that alpha is 43.36 degrees to 2 decimal places. Okay then, so how are the marks awarded in the second half of the question? Well, initially we get a standalone mark if you have calculated that the time at which the ball passes over the tree is 5/6 of a second. Next, we get a method mark if we've correctly identified the variables and the formula that needs to be used. And there's an accuracy mark if it's substituted into the formula correctly, which will result into our answer. Next, we get a method mark if you have used the magnitude of the resultant in order to find 28.89, which gets an answer mark. And then we get a method mark for stating that tan alpha is 119/6/21, and an accuracy mark if you come out with the angle of alpha as being 43.36 degrees to 2 decimal places. Okay, I hope that all makes sense and that you understood the answer to that question.